Hello and welcome back to Properties of Rectangles. Today we're going to be talking about properties of rectangles and how we can find angles and side lengths using them. First things first, rectangles have the same properties of parallelograms. In other words, opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, that's add up to 180 degrees. Diagonals bisect each other. The new one that we're going to add in for properties of rectangles is that all angles are right angles. Let's change that. All corners, got to be a little more specific, all corners are right angles, 90 degrees. The second one is that diagonals are congruent. It means that they're the same. Diagonals are congruent. Okay, let's go ahead and check out number one using these properties that we have here. Okay, up here it tells us each quadrilateral is a rectangle. Find the missing measures. Okay, so I'm just going to go through like we did with the parallelograms, and I'm going to mark up each side. So the 24 is congruent to SR. They're both the same because they're opposite. Same thing with PS and QR. We know that diagonals bisect each other. Okay, so that means that these are split into half. But we also know by our new rule that diagonals are congruent. So all diagonals are the same length. Okay, so this half is the same as this, same as that one, and this one. Okay, let's go ahead and fill the rest of this in. Let's see, QR. Okay, QR is 10. SR, that's 24. Put that on my picture. SQ. How do we know what SQ is? Well, this brings up a good point. Remember, all corners are right angles, so if I did this right here, okay, that makes a right triangle here in red. Just like this. This is our right triangle that we're dealing with. Okay, so to find SQ, SQ is the hypotenuse because it's across from the 90 degrees. So SQ is equal to SQ squared is equal to 10 squared plus 24 squared. So we have SQ squared is equal to 100 plus 576. SQ squared is equal to 676. If we take the square root, we get that SQ is equal to 26. Okay, so we fill that in. PR. Okay, PR is the same as SQ. Remember, diagonals are congruent. QT. QT is half of SQ, so if I divide 26 by 2, it gives me 13. Okay, number 2 you would complete in a similar manner. Let's take a look at number 3. Okay, the first thing that I look at in number 3 is this 27. Okay, remember that all corners are 90 degrees. So, if I was to find this red dot right here, excuse me, sorry about that. To find the red dot, okay, the red dot is equal to 90 minus 27. Okay, so if I do that, red dot is equal to 63 degrees. Okay, let's look at the red dot. The red dot is named by MJL. Those are my three letters. So start at M, go to J, go to L. MJL is right here, so I'm going to put my 63 for MJL. Okay, let's take a look at another one. MJK. Okay, that was actually the first thing that we did. Okay, 90 degrees. JLK. Start at J, go to L, go to K. So we're looking at this blue one. Yeah, I'm going to actually change the blue to the red because those are the exact same angles. How are they the exact same angles? Okay, these are alternate interior. So for this guy, I'm going to put alternate interior with MJL. Okay, so alternate interior, those are the same. That's also 63 degrees. Next up, KML. KML. Okay. This one's a little tricky. We haven't seen something like this before. Okay, so how are we going to figure that out? Well, first thing that we're going to do is we're going to take a look at this 27. We got to use what they already gave to us. Okay, so the 27 is part of this 90 degrees. Okay, because of the fact that diagonals bisect each other and our diagonals are congruent for rectangles, okay, this means that if I was to take this 27 and flip the triangle to where it matched up with this one, okay, so this corner, it would have to be flipped to where this corner comes this way. Wait a second, we're looking at this triangle right here. So I would take this guy and I would just flip him over and I would get the 27 right here. Okay, so 27, I could also fill in the 27 right here. Alternate interior. Okay, where else could I have a 27? Well, this one right here is the 63. This guy's 27. So is this one. Okay, so we got 27 degrees for KML. 27 degrees. MNL. MNL. So that's this one right here. Okay, we're going to figure that one out because we know that all angles in a triangle add up to be 180 degrees. So for MNL, okay, that guy is going to be equal to 180 minus this one right here, 27, minus this one, which is also 27. So MNL is equal to 126 degrees. 126. There we go. That's number 3. Number 4 is pretty similar to number 3. Okay, for number 4, the first thing that you need to do is you need to remember that if angles cross like this, okay, if you see an X, you could also say this is a V, this is an A. You have vertical angles. Okay, so that's going to be your little hint for number 4. Okay, I'm going to flip it over to the back side. Whoops. Okay, let's go ahead and take a look here at 7. Okay, so here's 7. Okay, if RT is equal to 5x minus 14, here's RT. Put him in blue, 5x minus 14. US is equal to 2x plus 10. I'll do US in red. Find VT. Okay, here's VT. So we're trying to find this black piece. Okay, so the first thing that I'm going to do is I'm going to set the blue and the red equal to each other. The reason I do that is because we know that diagonals are congruent. So 5x minus 14 is equal to 2x plus 10. Okay, I'm going to do my math, solve for x. Subtract 2x on both sides. And add 14 to both sides. I get 3x is equal to 24. Divide by 3, get x equals 8. Okay. Now to find VT, VT is half of RT. Okay, so I'm going to take my x and I'm going to plug it back into RT, and then I'm going to divide that number by 2. So RT is equal to 5 times 8 minus 14. Okay, 5 times 8 minus 14 is 26. Divide that by 2. Okay, and that gives me VT equal to 13. Key to that one is you got to plug back into the RT, and after you do that, you have to divide it by 2 because this diagonal is split into 2 equal parts. Okay, let's come down here and take a look at number 10. Okay, number 10 is kind of similar to the problem that we talked about on the front side, number 3. Okay, the reason I say that is because these two angles are alternate interiors. Okay, so since they're alternate interiors, we can say that they're equal to each other. So I'm going to say 7x plus 5 and 11x minus 3 are alternate interiors. Okay, so that means they're equal. 7x plus 5 equals 11x minus 3. Sorry, I got crooked there. Okay, now I'm going to solve for my x. Take away 7x from both sides. Add 3 to both sides. Okay, so these cancel out. And I get 8 is equal to 4x. Divide by 4, x equals 2. Okay, what do I do with this 2? Well, let's take a look at what we're trying to find. We're trying to find BCE. BCE. Okay, so this red angle right here. Okay, remember that these two add up to make 90 degrees. So angle BCE plus 11x minus 3 equals 90. Okay, now I'm going to take my x, I'm going to plug it in right here. When I plug it in, I'm multiplying. So BCE plus 11 times 2 minus 3 equals 90. Angle BCE plus, I got 22 minus 3, that's 19, equals 90. And then I'm going to take away 19 on both sides. Minus 19, minus 19. And we get BCE is equal to 71 degrees. There you go, ladies and gentlemen. That is number 10.